Hello everyone, I am Abhinav and today we will be discussing the second problem from the CP-31 sheet by TLE Eliminators under the 1500 rated questions. Okay, so let's move to our CP-31 sheet and we can see that the 1500 rated mark has been checked and we can see the clickable link for our problem. So we'll click at the second problem, which is Smilo and Monsters. Okay, so let's read the problem statement, what it states. A boy called Smilo is playing a new game. In the game, there are n hordes of monsters and the ith horde contains AI monsters. Okay, the goal of the game is to destroy all the monsters. To do this, you have two types of attacks and a combo counter X initially set to 0. Okay, so basically we are given an array A and A where this array, what does it represents? It represents that the ith index has AI monsters in it. Now what we need to do is we have two types of attacks in it and we need to kill all the monsters in this game. Okay, so there are two types of attack. First type is you just choose a number I in between 1 to n, such that there is at least one monster left in the horde with number I. Then you kill one monster from horde number I and the combo counter X increases by 1. Okay, so in the first type of attack you can just choose any index and kill one monster from that horde. Basically we have n hordes and kill, so just choose any index of the horde and kill one monster from that horde if there exists at least one monster there. Okay, so you need to choose a horde where there is at least one monster and kill that. And after doing this attack there's a combo counter X. So X is, you can understand it like a power up. You when doing the first attack, its power would increase by 1. Now you can utilize this X to do the second type of attack. In the second type of attack, you choose a number I from 1 to n such that there is at least X monsters left in the horde with number I. Then you use an ultimate attack and kill X monsters from the horde number I. After that, X is reset to 0. So basically using the first attack, you can charge up your combo counter X, and when it is charged up to some number, let's say X is 4, then what you can do is choose a horde where there is at least 4 monsters and kill 4 monsters from that horde. Okay, basically you can just kill X monsters at once using this ultimate attack of second type. Okay, and then your X is reset to 0. So that's what the second type of attack is. Now your task is to destroy all the monsters, meaning that there should be no monsters left in any of the hordes. Smilo wants to win as quickly as possible, so he wants the minimum number of attacks required to win the game. So basically you just need to find the minimum number of attacks required so that you kill all the monsters. You need to destroy all the monsters in minimum number of attacks. Okay, you can now look, the input format is n and an array of n integers. N is up to 2 into 10 to the power 5. Okay, so let's take the first test case and understand our problem statement. Okay, so here you can see in the first test case n is given as 4, so there is an array of size 4. Okay, so basically it just represent at horde, it's a, if I'm doing a 1 based indexing, then horde number 1 has 1 monster, horde number 2 has 3 monsters, horde number 3 has 1 monster, horde number 4 has 1 monster. That's what this array represents. Now we need to find the minimum number of attacks in order to destroy all these monsters. Okay, so what kind of attacks do we have? First, initially when we start, our X is set to 0. What is X? X is the basically the power up, the combo counter variable that was mentioned in the problem. So it is initially set to 0. Now, so initially when it is 0, we can't use an attack of second type. We can just destroy 0 monsters. So there is no benefit of using an attack of second type initially. So we can use an attack of first type. Okay, let's say we use it on this. So what would happen if you use an attack of first type and destroy this? It would reduce to 0. So one monster from this horde would be destroyed and our X would be increased by 1. So when we use an attack of first type, one monster gets destroyed. We can just destroy any one monster from any one horde. So if we choose this horde, one monster from that got destroyed, became 0 monsters remaining, and our power of this X charges by 1. Now when it is charged to 1, we can use an attack of second type to destroy one monster. but one monster we can destroy using an attack of first type also, so there is no benefit of using this second type. Better we'll use the first type only. Let's say we use the attack of first type on this second horde and we reduce this 3 to 2. Okay, so we have destroyed one monster from this second horde and our X is charged to 2. Now after this, what we can do, we can maybe use this X is equal to 2, so we can use an attack of second type to destroy two monsters at once. Okay, so now what we'll do, we'll use an attack of second type on this and destroy two monsters at once, so we can make it 0, and once we use it like this, our X would also become 0. Okay, so now since we have used an attack of second type, our this whole X is equal to 2, that is been used up to destroy two monsters, and it became 0 again. Now we can again, we'll have to use an attack of first type. Let's say we used an attack of first type and made it destroyed this monster, then this X would also charge up by 1. Now one monster is left, we can use either an attack of first type or second type, anyone, and kill that monster. Okay, so this is one way of killing all the monsters. Now how many attacks were required here? Like initially we used an attack of first type here, then an attack of first type here, then an attack of second type here. Okay, so 1 2 3, then 1 attacks of first type here. A total of 5 attacks were used in this case, what we did here. So what we need to find out in this problem is we need to minimize this number, the minimum number of attacks to destroy it. Like you can see in the first test case, the answer was 4. So actually we could have done this thing in 4 attacks only. How? Let's see how we can do it in 4 attacks only. So what we did here is used a first attack here, then a first attack here, then a second attack here, then again first attack here. That way we did. Now instead of doing that, what we can do is, let's suppose okay, let's suppose we have this array. Now our X is initially 0, so what we can do, we can use an attack of first type here, charge X to 1. Okay, one attack done. Then instead of choosing this horde, if we choose this horde and do our second attack here, make it 0, X got charged up to 2. Then we used our first attack to on this horde and made it 0, X got charged up to 3. Now since X is charged up to 3, we can use an attack of second type and destroy all these 3 monsters at once and make it 0. So this way we did 1 2 3 and 4. In only 4 attacks we were able to destroy all the monsters, and for this test case 4 is the minimum that we can achieve, because you can see the answer for this test case is 4. Okay, so by just analyzing this test case, we understood a little bit what we need to do in the problem. Okay, now how do we solve the problem for any array? Okay, what we can do, what should be our procedure in order to minimize? Okay, we'll think about it. Let's look at the constraints of the problem so that we can more understand what time complexity and all would be required. So we can see that n is up till 2 into 10 to the power 5 and ai is 10 to the power 9. Okay, so basically we are given that n is less than equal to 2 into 10 to the power 5 and our array ai is less than equal to 10 to the power 9. These are the constraints of the problem. So what we can understand is, if you let's say you are doing some brute approach where you are just decreasing this ai one by one, or something like this. If you are doing some approach which is going to the order of ai where every element is reduced one by one, that would go to something 10 to the power 9 order, and n elements are present here, so it would be product of this, something like that. That would not be accepted for sure. We know that these many operations we cannot perform. So what would be the expected time complexity for this problem is, we need to do something in this order of n. In order of n, what we can do, what if we apply something of n square, then that would become, the square of this would be 4 into 10 to the power 10 operations, which is still way more. Like in 1 second we can do 10 to the power 8 operations, so this won't be accepted. So we need to do something in order of n or order of n log n, that would be accepted, or even in the worst case we can do something in the order of n root n, Okay, that would be something in the order of 10 to the power 7, 10 to the power 8 only. So these are the you can understand from the constraints, these are our expected time complexities that we can have for our problem. Okay, so we need to solve our problem in something in order of n or n log n or something. In worst case we can go n root n. Okay, so now let's try to analyze how can we solve this problem in this time complexity. Okay, so this was our expected time complexity. Okay, so the first thing that you analyzed from the given test case only is that what was the best way to do it. Destroy this using the first attack, charge your x to 3 and then use just one attack on this and destroy this whole horde. Now when we were initially doing the first attack on this and then again the first attack on this only, we were reducing this 3 to 2. Now if this 3 is reduced to 2, in one time using the second attack we can only kill 2. So what's the best way? Like greedily only you can understand it is always better to perform the second operation on higher number and the first operation on lower numbers. Okay, this intuition you would have got by analyzing the test case only. Okay, so that's the first observation you can note down. Okay, now how can we solve this problem? One more thing what you can understand, what you need to find is minimum number of attacks. So what are the types of attacks? If we analyze, there is a type 1 attack and there is a type 2 attack. Okay, what if we don't have any type 2 attack? Then what would be the number of attacks required? If we only use the type 1 attack, then the number of attacks required would be just the sum of all the monsters, basically the total number of monsters. It would be killed one by one only. So it would be 1 plus 3 plus 1 plus 1. This would be the number of attacks required, which is 6. So there are in total 6 monsters here. So in total 6 attacks would be required of type 1 if we only have type 1 operations. Okay, now how can we reduce this is using type 2 operations, because in type 2 we can destroy multiple monsters at once. Okay, so we just need to maximize this type 2 operations. The more type 2 operations we have, the more number of basically the attacks we can minimize. So if we are using a type 2 monster at x equal to 3, basically you are destroying 3 monsters at once. So what if only using type 1 operation we had used 6 number of attacks. Now if we use one type 2 operation of x is equal to 3, so instead of using 3 attacks on these 3 monsters, we are using just one attack on these 3 monsters. So basically we are reducing our answer by 2. Okay, so this 6 got reduced by 2 and 4 became our final answer, because we used an attack of type 2 with x is equal to 3. So if we use an attack of type 2 with x equal to 3 and somewhere else we use with x is equal to 2, what would be the overall reduction? Due to this we reduce by -2 and due to this we can reduce by -1. That way a -3 overall we would have got. So with every attack of type 2 we are reducing our answer. So if we maximize this type 2 attacks, then we can minimize our answer. That's the second observation you can notice. Okay, now what we can do basically. Okay, so this was one observation. Then the first observation we already noticed that the greater the value, it would be better to apply type 2 operations on greater values. So what we can do is first sort the array, because we need to know which value is smaller and greater. So and also you can see that we can apply the operation, we can just choose any index and apply the operation. The order of these indexes doesn't matter. So if the question was 1311 or if the question was, let's say, 1131, the order does not matter, the question remains the same, because we are not doing the operations in the order of indexes. We can choose our index by our own. So we can just sort this array. Basically it would not affect the question if we sort this array. So first thing we would do is sort the array. Okay, now once this array is sorted, now through the first observation what I told you is we'll use smaller attack, the type 1 attacks on smaller numbers and the type 2 attacks on bigger numbers. So what we can understand from this is this would be a greedy approach that will start doing type 1 attacks on this. Now while it is charging, if we do 3 type 1 attacks, it would charge to 3. We can use a type 2 attack on this to destroy this 3. That way we can move. So what we can do, if we take some other test case, like say we take this test case. Okay, so what we can do here is, first of all, what I did is sort this array. So if we sort this array, it would become 1 2 3. Okay, there are 2 2s, 2 3 4 5. This would be our array after sorting. So what we can do is start doing type 1 attacks from this side, and once it is, and start doing type 2 attacks from this side. So if we do type 1 attack, 1 x would charge up to 1, then 2 type 1 attacks, x would charge to 3, then 2 type 1 attacks. So after doing these 5 type 1 attacks, our x would have charged to 5, so we can do 1 type 2 attack and destroy this whole 5. Okay, then we can do 3 type 1 attacks on this. Our x would, after doing this, x would have become 0, and then after doing 3 type 1 attacks, x would charge to 3. Now still using this 3, what we can do is destroy this 4 and make it 1, and then use a 1 type 1 attack to destroy it to 0 further. So how many in total attacks we used? 5 attacks here, 3 attacks here, 8, then 1 attack on this, 9, then 2 attacks here, 1 type 2 attack and then a type 1 attack. So in total 11 attacks we did in order to destroy all the monsters. You can see for this third test case our answer was 11. So we can see that this greedy approach is always working, that move from, sort the array, move from the left side, on the smaller values do a type 1 attack, on the bigger values try to do type 2 attacks when x is charged up till there. Okay, so if we just try to deep dive a little more to understand exactly what we are doing is, when we use a type 2 attack, okay, so if in total we say that our sum is, okay, if we say that sum represents basically the sum of AI, basically this whole sum. Here our sum was 5 3 8 4 12 and 5 17. Okay, 17 was our sum. So in this test case 17 was the sum. So it represents the total number of monsters present. Okay, the sum is the total number of monsters present. If we have 17 monsters present, then how many type 1 attacks we would have to use at least? If you try to analyze, then when we use 1 type 1 attack on a monster, we can destroy another 1 monster using a type 2 attack, because x is charged up by 1. If we use 2 attacks of type 1, then we can destroy 2 monsters using type 2 attacks. So if we have 17 monsters in total, then how many monsters would be destroyed using type 1 and how many would be destroyed using type 2? If you try to think, then half of the monsters would be needed to be destroyed using type 1 operations, then only the other half can be destroyed using type 2. So half of 17 is 8.5. so let's say you destroyed 8 monsters using type 1. If you destroyed 8 monsters using type 1, it means your type 2 has also charged to a total of 8. So you can destroy 8 more monsters using type 2 attack. Okay, that may be not using a single attack of 8 monsters, that would depend on the size of the hordes. It may take 2 or 3 attacks, but still in total 8 monsters can be destroyed using type 2 attack if you have destroyed 8 monsters using type 1 attack. Now in total 16 we destroyed, but we still have 1 monster left because we had 17 in total. So that we would have to destroy using type 1 attack only. So we can see that if we destroy 9 monsters using type 1 attack and 8 monsters using type 2 attack, then we can do this. Okay, so and we need to maximize the type 2 attack, so this would be the best if we are destroying 8 monsters using type 2 attack. We could have also done 10 monsters using type 1 and 7 monsters using type 2, but that would maybe increase our answer. We are not minimizing it because we can utilize more type 2 attacks. The more type 2 attacks we use, that would be the best. You can see greedily only you can understand that. Okay, so basically if we have a sum, what we can do is the number of monsters destroyed by type 1 attack would be sum by 2 the seal of sum by 2 we can see, because if it was 17, this was 9. And the number of monsters destroyed using type 2 attack, that would be the floor of sum by 2 we can say. Okay, this was the floor of sum by 2. So these are the number of monsters destroyed by type 1. So what would be the number of operations, the number of attacks that we are doing? So type 1, if we are destroying this number of monsters, this number of basically operations also would be required, this number of attacks, because in every attack we are destroying one monster. So this number of attacks for type 1. Now for type 2, if we are destroying 8 monsters, that's not requiring 8 number of attacks, but that's requiring less number of attacks. How much? For this test case, you can see one type 2 attack was used with x equal to 5, and then a type 2 attack was used on this with x equal to 3. So 5 and 3, in total 2 attacks of type 2 were used here. So for this test case, we can say that the type 1 attack, in total 9 type 1 attacks were used, and that these 8 monsters that were destroyed using type 2 attacks, the number of attacks used were 2. One using x equal to 5 and one using x equal to 3. Only 2 attacks of type 2 were required to destroy these 8 monsters. So we can see using 9 plus 2 is equal to 11 attacks we were able to destroy all the monsters. So 11 was our answer. So what we can do, what we can say, that in order to find our answer would be, this would be, so I can say my final answer would be sum by 2, the seal of sum by 2, these would be the type 1 attacks required, plus some number of type 2 attacks required to destroy this number of monsters. Now how can we find this number? That we can find by sorting the array and moving from the back. Okay, once we have sorted the array, we can move from the back, from the highest number. Let's take x equal to 5. So if we had to destroy 8 monsters, we already destroyed 5 and 8 became 3. Then if it was 4, so we destroyed this and it became 0. So how many steps was required to reduce it to 0? 2 steps were required to reduce it to 0. So we would add a plus 2 to our answer. So basically our answer would be initialized by this and the number of attacks required in order to kill these many monsters if we move from the highest order in our sorted order. Okay, so that's our approach. What would be its time complexity? If we look, in order to calculate this sum, it would take an order of n time complexity, and then if we sort this array, the sorting would take an order of n log n time to sort the array. Okay, sorry, let's write more cleanly. So in order to calculate the sum, that would take an order of n time complexity to calculate the sum. Now if we are sorting the array, that would take an order of n log n time complexity to sort the array, and after that we are just moving in this sorted order from the highest value. If we are moving, okay, then we need to calculate the number of steps to reduce sum by 2. Okay, this, how many number of steps are required in order to obtain these many monsters, in order to kill these many monsters. That would take the last thing, that would at max take order of n time complexity if we are moving to the whole array. So our overall time complexity is going to be an order of n log n. Okay, so we can see this was one of our expected time complexity, so we can solve this problem using this. Okay, I hope you would have got the logic what we are doing. Okay, let's take one more test case and just dry run to understand what we are actually doing. Okay, let's say if you have n is equal to 7 and your array is 3, 4, 9, 15, 8, 6 and 10. Let's say this was your given test case. What you would do, first sort this array. So after sorting, it would become 3, 4, 6, 8, 9, 10 and 15. Okay, this would be our sorted array. Okay, after that what we can do is calculate its sum. So its sum would be 3 plus 4 7 and 16 is 13, 21, 30, 40, 55. So sum here was 55. Then what we would say, our answer is initially 55 by 2. The seal of 55 by 2, that would be our initial answer, which is 28. And then to that we would add the number of steps required to kill 55 by 2 the floor, which is 27. So number of steps required to kill 27 monsters. So how many steps would be required to kill 27? We'll move from this side. So we can kill 15 monsters at once. Okay, so we had to kill 27, 15 monsters are killed, so 12 are remaining. So one step is utilized here, we would move here. Now we can kill 10 monsters at once, so 2 remaining and one step is utilized here. Then we'll move here. We can kill 9 monsters at once, but we only need to kill 2 monsters, so we'll kill 2 monsters and one step would be utilized here. So this would be our total answer, which is 31 in this test case. Okay, I hope you understood what we are doing here. So we can move to our code. Okay, so you can look at the code. What I'm doing is okay, one thing, I have defined my int as long. You can, using the constraints, you can see that AI is going up till 10 to the power 9, and if we are taking the sum, okay, if we are taking the sum of n integers, these many integers which are 10 to the power 9, it would go up till 10 to the power 14, you can understand. So this is exceeding our range of integers, so we would have to use long here. So in my code, what I'm doing, I'm just defining my int as long, so that wherever I've used int, that would be automatically converted to long, so I don't need to worry about my overflows and all. I'm using long automatically. Just keep in mind that you need to use int32t in your main function. If you're writing a normal int, that would get converted to long and give you error, so keep that in mind. So I have defined my int as long, so you can assume wherever I have written int, that is actually long. Now I'll take the t-test cases as input, and then inside the t-test cases I have an int n and array of size n. So these are the input part. Okay, this was just the inputs that I have taken. Now I'll move to the actual logic of the code. I'll calculate my sum using my accumulate function. I'm just calculating sum. You can run a loop and calculate a sum, no problem. Both would be the same. I've got my sum. Now my remaining would be the floor of sum by 2. Okay, so if I'm normally dividing two integers, I would get the floor value only. So in remaining, I got the floor of sum by 2, and my answer is initialized to ceil of sum by 2, which is same as sum minus floor of sum by 2. This remaining had floor of sum by 2. So what I did is I just subtracted the remaining from my overall sum, or you could have also written sum plus 1 by 2 to get the ceil of sum by 2. Okay, that's my initial answer. That's the number of type 1 operations that I need to do. Now I would sort my array. Okay, I have used rbegin and rn in order to sort it in decreasing order. So I have sorted it in decreasing order. So when I am moving in the array, I am moving from highest to lowest. Okay, that's what I needed to move. So I have sorted it in decreasing order. Then I am taking a loop from every element in the array. I am moving from the highest element to the lowest element. So for every element, I would check if my remaining has become less than equal to 0. I would break out of the loop. Otherwise, I would reduce my remaining by x and I'll do answer plus x. Okay, what I was doing here is I had initially my remaining as 27. I'm moving from this side. If x, I would reduce my remaining by 15. It got reduced to 12 and I did a plus 1 in my answer. Again, I reduced my remaining by 10. It got reduced to 2. I added a plus 1 to my answer. Again, I reduced my remaining by 9. This 2 got reduced by 9 and it became minus 7 and I did plus 1 to our answer. Now once this remaining became less than equal to 0, I break out of my loop. Okay, so you can see once this remaining become less than equal to 0, I broke out of my loop. And every time until this is not happening, I'm reducing my remaining by x. I'm doing an answer plus x. Okay, so this way I'm computing the number of type 2 operations required, and this was the number of type 1 operations required. So overall I got my final answer, the overall number of operations required, so that I'm printing. I hope you understood the logic of the code. What would be the time complexity using the code if we analyze? So this input part is taking, there are in total n inputs, so this is taking a time complexity of order of n, and then you can see the, okay, this input part is taking an order of n time, and then this accumulate function would also take an order of n time. in order to sum up all the n values. These are order of 1 operations. This sort would take an order of n log n time in order to sort, and then this whole loop is also running n times at max, so this is also taking at max an order of n time. So overall you can see that our overall time complexity for this problem would be, okay, so the overall time O of n log n and n, so the maximum value is n log n, so our overall time complexity for this solution would be n log n. And what would be the space complexity? The space that we are using is a n sized vector here, and then nothing else. Basically an n sized vector is only used overall, and then these some variables, so overall space complexity would also be order of n. I hope you understood the problem. This was a really nice problem to understand the greedy approach. Basically, whenever you have to find something, uh, whenever you have to use some operations and all, and you had to minimize the number of operations. For that, sorting was one way. In order, if you analyze from the test cases and all, greedy approach and all, if you analyze that somewhere it was beneficial to use the attack on greater values, so to do that you sorted your array and use one type of operation on greater values, one type of operation on smaller values, so you greedily approach this question. So this was a really nice concept in order of sorting, you can say. So I hope you understood the problem and all the logic. I hope you liked it. Thank you very much.